Alright, Chapter 30, Railway Tunneling. Um, test. Alright, cool. Railway tunneling. Introduction. Tunneling can be defined as an underground passage to transport passengers, goods, water, sewage, oil, gas, and the construction of the tunnel normally carried out with causing much disturbance of ground surface. The history of the tunnel is very old. The first tunnel was constructed 4,000 years ago in Babylon to connect the two buildings. The first railway with a tunnel was constructed at the end of the 19th century to connect Switzerland and Italy. The cross-section of the tunnel was shaped in a horseshoe, and its length was about 20 kilometers. On the Indian Railway, the first tunnel was constructed near the Thames Central Railway, known as the Parkinson Tunnel, the longest railway in tunnel in India, length about 1,370 meters. Um, Necessity advantage of the tunnel. Necessity of the construction of the tunnel may arise because of one of the following. A tunnel may be required to eliminate the need of long situated route to reaching the other side of the hill. It would considerably reduce the length of the railway line. May also prove economically provide the tunnel inside of the cuttings, particularly with the rocky terrain. Depending upon the various factors of the rough calculation, would indicate that for a small stretch of the land, cost of the construction of the tunnel would equal the cost of the cutting of the rocky terrain. And the hills, the soft rock of the tunnel is cheaper than cutting the metropolitan tool within the large city of the tunnels are constructed with accommodate underground railway system in order to provide a rapid, unobstructed means of transportation. Tunnel construction under a riverbed may seem sometimes provide more economical convenience than a bridge. In case the aerial warfare transportation, the tunnel provide better safety and security for the rail service and rail use compared to the bridge. And deep cutting, the maintenance for the cutting of the tunnel considerably lower than the bridge deeper cutting. However, the construction of the tunnels also has disadvantages in certain ways they enumerated here. The construction of the tunnel costly requires special construction machinery. Equipment. The construction of the tunnel involves the sophisticated technology requires experienced, skilled staff, and it's time-consuming process. Tunnel alignment and adjustment gradient. For precise details necessary before setting the alignment of the tunnel with the ground, the special error of the setting alignment would result in two ends never meeting at all. When starting the work at both ends of the tunnel, as well as the center line, marked with the precision of the ground, so that the correct length of the tunnel can be determined. Accurate survey then carried out to ensure that the center line of the alignment at the level that are traveled transverse properly to either of the underground position. The following points require special attention to deciding alignment and grading of the tunnel. The alignment should be straight as far as possible, normally such that the route which is shortest and most economical minimal possible gradient should be provided with the tunnel in an approach with the proper ventilation and adequate lighting should be provided inside the tunnel. The side drains and tunnels should be given a minimum gradient of 1 to 500 each for effective longer tunnels. Gradient should be provided with the center toward the end of the effective efficient grade. 33. Size and shape of the tunnel. Size and shape of the tunnel depend on the nature, type of the ground, and path of through, and as well as the design to carry a single or double the railway line. The shape of the tunnel should be such that the lining is able to resist the pressure as good of the unsupported walls of the tunnel excavation. The ground made of the solid rock of the tunnel can be given any of the shape of the tunnel. The rocky terrain is generally designed with a semicircular arc with vertical side walls. In this case, the soft ground with the such with the consisting of soft clay and sand. Pressure to the side of the top of the must be resisted. The circular tunnel is generally best suited with the resisting both internal external forces regardless for the purpose of the tunnel's use. Theoretically, the circular section provides large cross-sectional area with the smallest diameter that provides the greater resistance to external pressure, but this type of the cross-section is more useful than drains carrying sewage and fluids. Aqueducts built with the integration purpose of the railway track. Circular portion of the bottom of the tunnel has also leveled in order to lay the track and facilitate easily moving the muck in place with the concrete. The typical cross-sections of the tunnel figure 31 one section. Commonly adapted tunnels. The purpose of these tunnels are served enumerated in Table 31. 1. Shape and purpose of tunnels. Circular water and sewage, elliptical water and sewage mains, a horseshoe road and railways, arch, roof, and vertical walls, road and railways, polycentric cross-sectional view, road and railways. Alright, Table 31, typical cross-section of the tunnel, width, rain level, sleeper, the ballast wall, weep holes, drains, ballast, height. Side of the railway depends on the gauge of the railway track, number lines, the typical dimension railway tunnels specified in Table 32. Broad gauge, meter gauge, broad gauge, 1,676 meters, single line, 4,880 to 5,490, height 67,000, 7320, double line 8,530 to 9,140, height 6,000, 67,000, 6,700, 730, 7,320, meter gauge 1,000, gauge meter 4,270 to 4,880, single line 61,666, 6,166, 6,700, height, double line 8,530, 9,140, breadth, double line height 61,000, 67,000. Methods of tunneling. The various methods of tunneling. The selection method depends upon the site of the varying condition of the ground. With the equipment available to the extent with the timbering required, tunneling may be basically divided into two main groups: tunneling hard rock, tunneling soft rock. They're described in detail subsequent section. Tunneling through the water-bearing strata. Compressed air tunneling is discussed subsequently. 34.1 Tunneling hard rock. The following methods are generally employed with the tunneling hard rock. Full face method. The method normally selected for the small tunnels whose dimensions do not exceed 3 meters. The method of full face entire facade of the tunnel. Tackle at the same time vertical columns are erected at the face of the tunnel. A large number of the drills mounted with the fixed in these columns are suitable height with the shown in figure 3.2. Series of holes measuring 10 millimeters, 40 millimeters in diameter with about 1200 millimeters center distance with a drilled rock, preferably 2 rows. The holes in charge explosive ignited next to the muck removed before replacing processing of the drilling holes. 3220 shows the sliding drill, vertical column, sliding drill, full face method. Advantages similar since entire section of the tunnel is tackled at more than one time. The method is completed expeditiously. Running tracks with track of the collecting muck that can be laid on the tunnel floor, extended with the work of the progress which was developed in the jumbo drill carriage method can be used with a large tunnel. The method requires heavy mechanical equipment and is not very suitable for the unstable rocks. Can normally be adopted in small tunnels only. Heading and the benching method. The method of heading the upper half of the tunnel is bored first, then the bench of the bottom half, lower half follows. The heading portion is about 3.7 to 4.6 meters ahead of the bench portion. In hard rock, the drill holes bench are driven in the same time. Removal of the muck. The hard rock permits the roof to stay in the place without supports. Heading of the bench method. The heading of the bench, the muck. Okay, the advantage of the working drill holes for explosive removal of the muck that can be progressively simultaneous. The method requires lower quantity of the gunpowder from the full face method. The drill method. Drill method, small tunneling measured 3 by 3 meters, which is driven in the rock. The wool section within the subsequent process still equates the tunnel. Number of the drill holes are provided all around the drift. These are filled up with ammonia, with the explosive ignited. The sum of the side of the drift expands to become equal to the required cross section of the tunnel. The position of the drift depends on the local condition. It may be the center or the top of the bottom side between figure and 30 and 4. The field experience should be the central drift the best choice. Offers better ventilation, requires lower quantities of explosive side of drift. However, the advantages that permits use of timber support over the roof. Advantage. Quality of the rock is bad. It contains excessive water that it detects with advance with the corrective measure that can be taken in time. The drift assists with the ventilation tunnel. The quantity of explosive is less. The side of the drift allows the use of the timber to support the roof. The time consuming the process of excavation manual tunnel gets delayed until the drift is completed. The cost of drilling and removing the muck from the drift is high as the work is done usually in manner operated power-driven machinery. Alright, this shows your bottom drift, your top drift, your center drift, and your side drift. Alright, pilot tunnel method. The method normally involves digging 2 tunnels, namely the pilot tunnel, the main tunnel, the cross-section panel tunnel that usually measures about 2 by 4 by 2 by 4 meters. Pilot tunnel driven parallel to main tunnel connected with the center line with the main tunnel. Cross cuts as many points, and the main tunnel is then excavated. A number of points the pilot tunnel offers the full advantage. Cross cuts main tunnel, pilot tunnel helps remove the muck of the maintaining the tunnel quickly. It helps to provide proper ventilation, lighting of the main tunnel. Method of however requires construction additional tunnel. Therefore, time and the cost of construction is higher compared to the methods described before. Parameter method of tunneling. In the method of excavation carried out along the parameter and peripheral of the section, the method is known as the German method. 34.2. Tunneling the soft ground and soft rock. Tunneling the soft ground and soft rock is a specialized job that does not involve the use of explosive requisite excavation work is done with the use of the hard tools, pickaxe, and shovel. The necessary sometimes compressed air has also been used for the purpose of during the excavation. The rail requires support for the sidewall roof. Depending on the type of the soil, the support can be provided in the form of timber, steel, plates, and other similar materials. The various operations involved with soft rock tunneling are as follows: excavation, mining, removal of the excavated material, scaffolding, shuttering, linking, lining of the tunnel surface. The nature of the ground is the most important factor in deciding the method that you use. Tunneling type of the ground is generally encountered in the field table in 1033.3. In the case of soft rock selection method, the tunneling depends on the following important factors: nature of the ground, size of the tunnel, equipment available, sequence of operations. Some of the important methods of tunneling in soft rock is described in the following section. Four polling methods. Four polling method is the oldest method of tunneling through the soft ground, and the method of the frame is preferred. The shape of the letter A, the place near the face of the tunnel is covered with a suitable plank. Poles are inserted at the top of the frame and up to variable depth. The excavation is carried out below these points where they are supported with vertical points. The excavation is carried out on the sides of the excavated portion suitable to support of the timber. The entire section of the tunnel is covered. Thus, the process is repeated at the work and progress. The cross-sectional view shows the wooden pole sheet, four-pole support. The four-poling slow, strenuous process requires skilled manpower and strict supervision. The method is meticulous and repeated in sequence. There is no shortcut for the same method. For the shortcut for the same. Alright, your linear plate method. Linear plate method timber replaces the standardized pressure of the steel plate. The use of pressurized steel plates have recently developed the method following advantages. Linear plate, the bench, the linear plate, trench jacks. Linear plates are lightly and can be handled easily. Normally, the joints of linear plates are bigger than size, but such maintenance cost is low. Steel plates are fireproof and can be safely used while working in compressed air conditions. Necessary work can be done with semi-skilled staff. Considerable saving terms of the excavation concrete required. Alright, your needle beam method. Needle beam method, figure 38, the depth of the terrains and soil permits the roof of the tunnel section stand without support for a few minutes. In this method, small drift is prepared with the inserting needle beam consisting of two rail sections, steel joists, and one section is bolted together wooden block in the center of the roof of the support with the landing carried out the wooden beam. The knee of the beams are placed horizontally in the front end of the support with the drift, rear end support with the vertical post, resulting in the lining of the tunnel. The jacks are fixed to the needle beam. The tunnel section is excavated suitably incorporating timber. Method of tunneling is not more economically compared to other methods. Figure 1038 shows the needle beam method. The support needle beam, the tick post, needle beam, lagging, jack, and plank. Also your lagging, your jacks, and your needle beam section. American method. The method figure 30.9, drift and driven is done on top of the tunnel. The drift is supported with the lagging cap, the two vertical posts. The side of the drift are then widened in addition with the support to provide the timber planks and the struts. Processing wine continue until result reaches the spring level. Well plates are fixed in the springing level, which returns the support of vertical posts. The vertical posts are now occupying the entire roof level. The posts support the drill and drift can then be removed. The tunnel working can be continued further in similar manner. English method. Similar to the American method, except with the roof loaded support with underpinning instead of using vertical posts. The drift is driven into the top of the tunnel about 5 meters ahead with the existing arc lining. The drifting and subsequent widening. Both spaces supported with the crown bars and posts. The work is carried until the spring level is reached. The sill is then extended across the tunnel. An extended piece of the support underpinning of the methods requires good quality timber as well as simultaneously frequently shifting from place to place. Figure 30.9 shows the American method. The wall plates, lagging cap, drift, shoulder timber, vertical posts, sills, and struts, and posts. Alright, your Australian method. Methods used for the long tunnel, particularly those at the great depths where the wall of the excavation may be yielded under the weight of the cover involved. The excavation will hold the section of the short length, furnishing the side walls and the arch. The Belgian method is particularly suitable to areas where the height of the overburden and the less of the surface is not distributed. In this case, the heading of the excavated work supported by the crown bar post, laggings the side of the excavated necks supported by the crown bars post, and finally the work of the lining of the arc carried out with the further excavation is done. 34.3. Tunneling with the water-bearing strata. The tunneling through subaqueous water-bearing strata is quite a different job. Shielding tunneling is generally preferred. In such case, the shield is movable frame. There is used to support the face of the tunnel. The tunnel is excavated in line under the protection of the shield. Shield is a device meant with the excavation to be carried out with beneath the water-bearing strata that basically consists of the cutting-edge skin plating in the form of the shell structure and hood of jacks, ridden girders, shifting steel plates, ports, as well as port doors, tails, and various methods of shield tunneling through the different type of the soils enumerated in table 34.3.4. Soils constructed using shield methods usually have circular section because of the following consideration. Rotation of shield is easily circular section. Grant protection is primary. Lining the circular section provides the maximum cross-sectional area of the smallest parameter. Circular section ideal suited for the resist semi-fluid pressure exerted soft ground. Alright, 34.4, compressed air tunneling. The method is possibly the most modern method of tunneling the compressed air with a pressure of 1 kilogram to 3 centimeters square. The forces enclosed with the space within the tunnel side at the top of the tunnel do not collapse, remaining in their position. The equipment of the tunnel consists of the bulkhead, which is an airtight diagram with an airlock. The airlock is an airtight cylindrical sealed chamber with a door at each end of the upper ends. The tunneling means compressed air quite difficult to process for the following reasons: pressure inside the air, earth value at the bottom and the top of the tunnel, the possible exertion Pressure of the floor of the tunnel depends on the nature of the strata. The pressure of the varies the strata depending upon the moisture of the content, which is difficult to ascertain. The compressed air normally escapes the pores of the air pressure of the diminishes continuous application. The air pressure has to be varied from time to time in order to achieve balanced value. The determination of the value depends more on experience than technical consideration. Alright, 3.5. Ventilation of the tunnel. The tunnel should be properly ventilated during as well as the construction of the reasons given below. To provide air, fresh air for the worker during the construction, move the dust degrade with the dirt, blasting, and tunneling operations. Remove dynamite fumes, other objectable gases produced by the other dynamites explosive. The methods listed below normally adopt the ventilation of the tunnel, illustrated in figure 310. 310 show the ventilation of the tunnel, airtight value of the tunnel, and fans. Natural method of ventilation. They achieve the drilling of the drift in the tunnel with the portal. In most cases, natural ventilation is not efficient, and the artificial ventilation is still required. Mechanical ventilation. Below method of fresh air through the fourth pipe of the fabric duct with the means of the fan supplied near the washing face. Drill face drilling operation required the washing of the bore holes tubes. Method of advantage of the fresh air supply with guarantee with the required most disadvantage for the foul air fumes that have traveled a long distance before they can exit the tunnel. In the process, it is possible that incoming fresh air will absorb some of the dust and smoke particles. Mechanical ventilation exhausting method. The exhaustion blowout method, the air fumes are pulled out through a pipe expelled by a fan that sets up an air current that facilitates entrance fresh air into the tunnel. The method that has advantage of foul air kept out of the washing face. Disadvantage, however, the fresh air has traveled a long distance before it can reach the washing face, during which period it may be absorbed some of the heat and moisture. Or your combination of blow-in, blow-out method. By a combination of blow-in, blow-out methods using a blower and exhaust system, respectively, a tunnel can provide best ventilation. After blasting and grounding the exhaust system, used to remove the smoke and dust. After some time, the fresh air blown in through the ducts and rotation fans reversed in the reverse flow of the air. Lighting of the tunnel. It's very important to ensure the tunnel is well lit, and some of the various activity operation involved with the tunneling can be carried out effectively and safely. The common type of lighting equipment normally used in tunnels: electrical lights, coal gas, silicon gas lights, lanterns. Electrical lights are considered as best option. They radiate bright light, and they are required to intensify the freeze of the smoke, and they are easily maneuverable from point of view, expansion, etc. Placed where the plenty light should normally provide the operation points, equipment station, bottom of the shaft, storage points, tempering stations, and underground repair shops, etc. 3.7. Drainage of tunnels. Good drainage of tunnels is very essential in order to them to operate safely. Smoothing of during the construction period, as well as afterwards. Source of the water's purposes include the groundwater collected from washing the bore centers hole with the water seeping through the ground, as well as the washing through the boreholes is collected in sump wells pumped out, and the tunnel is a long number of sump wells to provide with the collection of water. After the construction, the drainage ditch is provided along with the length of the portion of the tunnel. The slope of the portal wall towards the sump well are then used to pump out water. Shaft of the tunnel. Shaft figure 13, 30, 11 vertical wells and passage construction along the alignment tunnels. One more points between two entrances left. A shaft provided with the reasons should be listed below. Figure 3011 show the tunnel shaft. Portable adit, tunnel shafts, working shafts. Provided with the expeditious construction tunnels tackling the same number of the points. They're generally vertical of the minimum size of 3.7 by 3.7 meters diameter, 4.3 meters. Ventilation purposes. In order to ensure the ventilation, these shafts generally include the heavy girder size with a 1.2 meter diameter. Alright, 3.9. Lining the tunnels. Tunnels are a loose rock with soft soil is liable to disintegrate. Therefore, the linings are provided with the strength there for the side roof to prevent them from collapsing. The objective lining in the follows the strengthening side of the roof to withstand pressure, preventing the tunnel with the collapsing. Provided with the correct shape with the side cross-section tunnel to protect the leakage of water from the side to the top. Binding loose rock, providing stability with the tunnel, reducing maintenance for the cost of the tunnel. Sequence of lining. Lining of the tunnel is done by the following steps. In the first stage, gunting the down with the seal of the water in the rock. Seal the water in the rock tunnels. Concrete lining is done either on one attempt. The case for the circular tunnels are separated, tackling the vest side walls through arcs. Small tunnels, pressure 1.2 to 3 millimeters diameter. The concrete linking is provided with a hand placing method. In this case, bigger tunnels, concrete pumps or pneumatic placers are used in placing concrete. Concrete is cured to maximum strength. Humidity inside the tunnel is not sufficient. Curing the air. Curing can be done spraying water through the perforated pipe. The different type of lining practice is adopted anywhere else depending upon the ground condition. The figure 3012. 3012. Lining of tunnels. Roof arc firm bench. Roof arc firm bench. Roof arc firm bench. Invert. 39. To type of the thickness of the lining. The theoretical lining provided for the inside of the tunnels may be timber, iron, steel, brick, and any other construction material. Particular practical terms lining provided commonly used is that the reinforced concrete surfaces of the concrete linings provide the tunnel because of superiority structural strength, ease of placement, durability, low cost maintenance. The thickness of the concrete lining depends on the various factors: condition of the ground, size, shape of the tunnel, soil pressure, method of the concrete. The thickness of the concrete is calculated in the following empirical value: T is the thickness of the in centimeters, D is the diameter of the tunnel meters. T equals 83 thousandths of D. On the basic field experience, rail engineers have devised a thumb rule providing 2.5 centimeters lining with every 30 centimeters of diameter of the tunnel. As per thumb of the rule, the thickness of the lining of the tunnel is 1 meter. Diameter would be 100 divided by 30 or by 2.5 is 8.3 centimeters. Maintenance of the railway tunnels. The proper maintenance of railway tunnels is very important, but the point of the review with the safety of the train as well with the traveling public in order to ensure the railway tunnel is in good condition all year round is inspected in the following ways. Inspection by the assistant engineer. Part of the route inspection of the tunnel is inspected with the detail of the assistant engineer once a year before onset of the monsoons. All substructure in the tunnels are inspected with the aspect that require attention and record. Inspection of permanent way inspector. The permanent way inspector inspects the tunnel in detail once a year after the monsoons over the paying of the particular attention to the track, its components, aspects that requiring attention will be taken care of immediately. Inspection of work inspector. The structural portion of the tunnel is detailed once a year. The inspector of work inspector is always subcomponents of the structure and examine detail of the parts and require attention and attend to the planned way. 30.10.1. Detail of the tunnel inspection. The following feature of the tunnel detail inspection examination. Portal to either end. The inspected association whether any assignment of the slip of the slopes above the portals, whether the masonry, any of the work away cracked, shaking, bulging, whatever any of the apparent signs of movement. The section of the tunnel relation to the movement dimension. Inspection done with the check of the section whether the stage straight, routes or curve that conforms to the schedule and the dimension. Tunnel walls and roof layers inspected with the case that the line tunnels in certain with line satisfactory condition. Double places such as loose projects should be tapped off and checked with the following sound loose rock. Drainage. The inspected for the certain whether the side drains are adequate. Function ventilation shaft. The inspection of the certain whether the ventilation shafts are adequate, free from ventilation, other growth. Lighting equipment, special tools. Inspection for these features are required in certain lighting equipment, special tools where it's applied in good state. The track is inspected. Certain with the line and the level of correct, including the approach of the rail, sleeper, the fastening should be particularly examined. And corrosion. Alright, 3.11. Safety of the tunnel construction. Tunnel is difficult, hazard, time-consuming process of the whole operation done systematically, so if the ensure that at all times normally acts in the tunnel under the following condition: following rocks during the load, unhawking of the bulk, poor holding, handling of explosives during the shaft operation, cramped working space. The following tips are suggested for preventing accidents during the tunnel operation. Equipment and tools should be in good working condition. Regular detailed inspection should be carried out during the tunneling operation. Visual inspection should be done to detect seam in place of the weakness of the void. Falling rocks, there should be a provision sufficient support ensuring the tunnel is done properly to avoid collapsing of the tunnel as well as the falling rock. There should be provision of good lighting, non-slippery walkways, which partially help the revealing of the strain, the cramped workspace. The provision should be made with removal of extra debris, refuge of them for good drainage in order to avoid the accidents. Efforts should also be made to provide good ventilation. Telephone facilities should be provided, particularly inside the shaft, at the other places in the tunnel, to ensure smooth and accident-free operation. Firefighting equipment should be provided at all key points. Safety signboards should be provided at all key locations. All workers should be medically and fit to work inside the tunnel, and they should be examined periodically. Doctors, or state facilities should be available on site. Wearing of helmets by all workers employed in the tunnel should be made mandatory. Summary. The tunnels are required in special circumstances of what the track cannot be laid with natural ground when it is not economical. The construction of the tunnel very tedious specified work. Therefore, the very judicial decision required to come to the tunnel selection. The method of equipment required to construct the tunnel would be dependent on the nature of the soil. Tunnels should be provided with adequate light ventilation and other safety features. Chapter 31. Signaling and interlocking.